Hey, Walter Sorrells back with more tips for the knife maker. Today, the Eclipse project. So over the course of the next week or so, I'm going to kind of compress about a month or so of my life into maybe 4 or 5 episodes. I haven't really decided yet. But the idea is to give you a flavor of how a knife comes together in my shop. Some of it is going to be day-to-day stuff. Some of it's going to be more technical, how to make a knife type stuff. Today, I'm going to focus on the design of my new Eclipse. That's this knife right here. Okay, so here's a computer rendition of it. Now, at the end of this process, we'll see how it actually came out. But during this video, I'm going to be kind of jumping back and forth to the computer here to show what I'm talking about. And at the end of this process, we're going to see how it actually came out. Anyway, when I'm showing how I make a custom type knife in my other videos, you know, one-off, maybe I make it with a file, maybe I make it with, you know, a CNC machine like that back there, maybe I make it with a Harbor Freight belt grinder, maybe I make it with an angle grinder. The point is to show the technical progression of how a knife could be made. It's purely a how-to thing. Now, the fact is, when it comes to making knives, there's not just one how to make a knife. There are a zillion different ways. It's going to be different every time I show it so that, you know, you can tailor it to whatever kind of shop you have, whatever tools you have, whatever your skill set is, all that sort of thing. Here's another way of putting it. This series is not about how to make a knife per se. It's about how to be a knife maker. And again, there are as many ways to be a knife maker as there are knife makers. So what I'm showing here is just what I happen to do. It's a little slice in time, that's all. You know, over the years, I've forged knives, I've done stock removal. Every way of making a knife you can imagine, I've probably tried it. So there's no lesson here about how somebody ought to be making a knife. Again, this is just a month of me doing my own thing, a slice in time. So a couple of Australian knife makers came by my shop here a couple weeks ago, and I was trying to explain how I made things on my CNC machine, and I was really kind of struggling to communicate just the complexity of actually designing a knife for CNC processes. And what I said was that you make the knife in layers, and you know, Bjorn Jacobson, who was one of the guys that was here, he kind of looked at me like this. And I think probably what he understood me to be talking about was physically like layering something up like you would on a 3D printer. That wasn't what I was talking about at all. The idea here was that I was talking about the processes. So you're stacking up a whole bunch of processes. And that's really what we're going to be talking about here today. So what I was getting at is that if there's a stack of processes, if that bottom layer doesn't work, it doesn't matter how great a job, you know, all the subsequent layers are, all the things that you do after that point doesn't make any difference because the bottom layer doesn't work. So an analogy here would be building a house. You know, you got to build the foundation, then, you know, stringers and joists and stud walls, and, you know, finally you get to the roof and the mechanicals and, you know, the electrical and all that stuff. And if you do any of that out of sequence, it's not going to work very well. So building stuff on CNC machines and really just knife making in general is always about doing stuff in the right sequence. All right, let me jump back to my computer to give an illustration here. So I'm not actually going to show the Eclipse all the time. It's really complicated and it evolved over like months. So let's say you make a knife. We're calling this the world's ugliest knife. Square handle. Got a pokey little blade here. Couple holes for handle pins. Bam. So we're done. We just designed a knife. It's easy, right? Any moron could do this. Now, after I decide that, you know, after I'm done with this, I decide, let's say, that I want to make a Kydex sheath. It's going to go into a Kydex sheath. Well, Kydex relies on having some kind of detent so that the knife, here's an example. I mean, this is actually the Eclipse. So it's got this retention feature right here. Well, you'll notice that what we designed here doesn't have anything to grab onto. So there's nothing sticking out down there. There's no guard, no ricasso that would allow you to grab hold of it. So we'll just make a finger notch. Okay, but wait, the idea here was to make the world's ugliest knife. Now, it's only the world's second ugliest knife once it gets this little finger notch in it. So we got to do something different. Okay, so this goes away. Let's put a detent in here. All right, so I'm going to skip forward a little bit because, you know, it's a very long and boring process to put this little detent in here. Looks very simple, but it just happens to be something that's kind of complicated to do on CNC. So I do all that. Well, damn, now the detent is interfering with the location of the handle pins. So I could move the handle pin back, but now you got this big giant area here that's unsupported by your handle pin. The handle scale's not going to fit properly. It's going to, you know, crud's going to get underneath it. It'll probably crack off. You can't go this way. So you could go the other direction and move that pin super close to the edge. Now, aside from the fact that it looks terrible, and I know we're trying to make the world's ugliest knife here, but you don't want to put a pin this close. I happen to know from experience that the scales are going to tend to crack if there's any pressure against the walls of that little hole. So you get the point. This is one of like 80 variables that have to be worked out in every single design. Now, of course, if you've been through this design a whole bunch of times, I've been doing CNC type stuff for, gosh, 8 years or something like that. So I know maybe 65 of these things to avoid, but that still leaves 15. I'm just, you know, obviously I'm just making up numbers here. But the point is, every single design's different. If it weren't, it wouldn't be a design, right? It would just be a straight rip-off of something else. Hey, by the way, I just shipped the first batch of Eclipses. I still have a few left, so stop by tacticsarmory.com if you like the looks of this knife and pick one up for yourself. All right, let's get back to it. So what I'm trying to do here, and everybody's trying to do when they design a knife, is to make something reasonably new and fresh, which is not easy to do given that people have been making knives for, you know, 100,000 years. But obviously you also want it to be functional, and most important when you're doing something, well, when you're going to be making the knife yourself, it's got to be makeable. It's got to be producible somehow. Now, if you're just making knives for fun, it's okay to build a bunch of mistakes into the design that are going to require a whole bunch of handwork and fiddling around and in-process modification of your idea. Hey, it's not a chef's knife like you originally planned. It's a 6-inch long paring knife. And, you know, you just took 2 inches off an 8-inch knife and made it skinnier and all that. Who cares? But if you're planning to make it as a production knife, and I don't mean hundreds of them necessarily, but even if you're going to make 5 knives for your friends, you want to make it so that when you're getting close to Christmas to make these knives for your family members or whatever, that it's actually doable, you know, in a reasonable amount of time. So if you don't get this design reasonably right, then you're going to spend all this time chasing all these little goof ups that you made. And obviously in a production situation like I've got, it's got to be dead perfect. And this is why prototyping is important. So what you do is you work through the idea. You know, you start with this super simple, dumb little design here. Then, you know, you get it to a certain point, and then you actually make a physical knife. And in this particular case, let me see what I did with it. I believe that this was actually the very first prototype of the knife. And so, it really, like I said, I've done this a bunch of times, so it came out pretty close to where I wanted it. But it's not always going to be like that. You want to be able to see how everything hangs together. It's great looking on the computer screen, let's say, but you might decide after holding it that, it doesn't feel right in your hand or something, or it doesn't cut right, or the angles of the bevels seem too shallow or too heavy. It could just be a million different things. Anyway, here's the key point about the way that I make knives. The basic profiling and drilling and that stuff is done on the CNC machine. Now, I've been making knives for 25 years, and I can make them with a file, I can forge them, I can do them with an angle grinder. Of course, I can do them with a belt grinder. I've done a zillion knives that way. But this way, CNC is where I've landed in recent years. That's the tool that all this has to go through. And so the design has to fit that narrow little window. So any machinist will tell you that at least half of machining is holding the material in the CNC machine. This is a big part of where the creativity and the work comes. So what that means is that as you design the blade, you got to keep in mind how it's physically attached to the table in the CNC machine. In this case, you can see that I've actually designed that whole process right here. So I kind of developed this system back in the day that works for me. I'm not the first person to use this, but these are called the Pearson pallet system. This is the computer model for it, and then here's how that actually looks inside the CNC machine. Basically, these are big aluminum blocks that have a location feature on the bottom that's made out of steel and is very accurately machined so that you can drop it onto this base, and every single time you drop it on, it's going to be in the same position to within a few 10,000ths of an inch. Anyway, it takes quite a bit of time and fussing around to make these little pallets, so you really need to be sure about what you're doing when you design them. Over the years, I've tinkered around with the basics, and I've gotten more and more refined over time in terms of how I lay these things out and how they work and all that stuff. But it does mean that every single solitary aspect of the knife has to be, made to play nice with this pallet system. And if you don't do that, then you might as well throw this fairly expensive fixture in the trash and start over, and you don't want to have to do that. So basically the way this is going to work, you're going to drill the holes right here, then you move the blade to another station. When I say the blade, I mean the actual physical piece of steel, which is just a blank at this point. So you're moving that blank to another little station right here. You're going to mill out the profile, maybe some other features depending on the knife. In this case, there's a little border around here that gets a radius put on it, and then the knife gets flipped over to a second position, I guess really a third position, and you machine some other little features, and then you pop that out and you put it on the front and do the bevels. So what that means is that every hole, every bolt, the jimping, all this stuff has got to be exactly figured out before you ever put it on that pallet, or before you make that pallet. So a mill like this Haas is capable of generating a ton of force. So it can literally smash itself to bits if you program it to do the wrong thing. So moving around oblivious to where the fixture is, where the pallet is, and all that, you can just smash the machine to bits. So for one-off pieces like this, you got to go extra slow And, you know, basically you're cranking the feed down so that how fast the tool moves around in there, you're cranking that down super slow. You know, you may be stopping in the middle and looking at it. You're just on high alert the entire time, kind of easing the tools into position. It's very, very painstaking. And if you make one mistake, you might have to, again, chuck this piece of aluminum. Even if you got it all planned out right, if you executed it wrong, again, it can go into the trash before you get to the end and you got to start over. So all of that stuff has to be anticipated in the original design. There are a lot of things that can go wrong, and so you have to plan your way around not only the knife design per se itself, but you also have to plan around all these features that are unique to the fixture itself. Anyway, once you have a prototype, you've gone through all this rigmarole, and so you get to the point where you actually have a knife and you assemble the whole thing and all that. You know, at a certain point, you have to actually make the sheath, right? So in this particular case, it's a Kydex sheath. With Kydex, you really have to think the whole thing through, and so the design of the knife has to anticipate this Kydex sheath. And in the case of this knife right here, you know, I took several stabs at the sheath, no pun intended, and I'm not going to go into that any further. I'm going to talk about that in another video, because as anybody who's been following me, you know, for the last few months knows, I'm kind of refining how I'm doing my Kydex sheaths. I'm doing it differently than I used to. Anyway, what I will say is that, you know, it might seem like the tail wagging the dog, but in some sense with a tactical or an EDC knife, you really have to think about, well, how are you going to carry this? In this case, it's designed to be carried in a pocket. You know, it's got this little clip. But I had to sort of work through that a good bit to get to a point where I was happy with how this clip system worked. And, you know, it's entirely possible. I mean, again, of course, I've been through this a whole bunch of times, so I can anticipate most of the problems. But, you know, it's entirely possible for you to do all this crap and get to the other end, and you're just like, you can't get there from here. The knife just won't function properly with the sheath. And that's going to mean you got to go all the way back to the beginning and kind of restart the process. And that's just, you know, that's just one among many kinds of things that you might have to, you know, work your way through in this sort of iterative process to get from, you know, a neat looking idea on the screen, world's ugliest knife, or whatever it is you're trying to do, to something that's practical and, you know, that you can actually carry in your pocket or on your belt, or whatever it is you're intending to do with it, and have it actually function as a knife. So anyway, it took me about a month to get this design from, I mean, honestly, it probably was more like 3 months, but the bulk of the work happened in about a month. You know, so what are you working out? I mean, I've kind of talked about a lot of these things, but I mean, just as, for instance, this has jimping here, you know. The jimping is done by drilling little holes in here. Should these holes be 1/16 inch? Should they be 3/32? Should I mill them, you know, with an 1/8 inch end mill? There are a lot of different ways to do it, and there are advantages and disadvantages to all of them. Some of them is just, does this look cooler? Does it feel better in the hand? A lot of little variables, and you have to go through all that stuff. What's the right bevel angle? You know, how deep should, these are countersunk here, so you use an 82 degree countersink to go into here, and I got that depth wrong the first time, and I had to go back and re-drill all these little countersink holes by hand. In fact, in this particular case, I'll probably actually still redesign this handle one more time so that these little bolts will perfectly fit into these countersinks, and they won't hang over the top at all. You know, it's it's a whole lot of work just for that tiny little detail of, you know, maybe 0.010 of an inch of stick out of these little bolts. But that's just kind of what you strap in for when you do this CNC stuff. Anyway, couldn't show you every dinky little change because that would have meant filming this whole process for about a month. But I hope you get the idea here. You know, I've said it many, many times, but a lot of people, I think, get the misimpression that you just hit a button on a CNC machine and a knife pops out. Believe me, it is nothing like that. Anyway, hope that gives you a good flavor of how this part of the process works. Next, I'm going to be leading on into a little more of the CNC side of it. And, you know, what I'm trying to do with this series is also to, how would I put this? You know, to show you the texture of what my job is like, as well as the actual, you know, how-to type stuff. And so I'm also going to show you some of the things that I do that have maybe absolutely nothing to do with the Eclipse itself, but just give you a flavor of, you know, what it's like to be, you know, a knife maker on a day-to-day basis. All right, guys, thanks for watching, and we'll see you soon. Thanks for watching, guys. If you like what we're doing here, please subscribe and make sure that you click on that bell so you get notified of all the latest videos. Want to buy a knife from me? Check out my modern blades at tacticsarmory.com. Digging the channel? You can support our video making efforts on Patreon. You know, I've been banging away on these videos for like 10 years, so I hope you'll show some love for all that hard work. Link in the cards and descriptions. Finally, if you're interested in making Japanese swords, check out my full line of Japanese sword videos where I show how to forge Japanese swords as well as how to polish them and how to make fittings, handles, and scabbards. WalterSorrellsBlades.com.